Hello everyone, welcome back to a new episode of Advent of Code. I finished up 12 since the last time we talked. The problem was just that I picked an index where the pattern hadn't started repeating yet, and I just assumed it would have repeated by then, but it didn't. So after that, the approach that I had tried to take worked fine. So today we're going to move on to 13, and I've already done a fair bit of work for this one off camera, but it's been sort of just modeling work and not any actual algorithmic stuff, I think. It's not actually that much algorithm to do here, but okay, I'll read you the puzzle. Well, tell you what, you guys can read this yourselves if you want. I'll just summarize it so we can get going. Basically, we're given a map of mine carts, right? Is what this is supposed to be about. Carts moving around on fixed tracks. And it's drawn for us in our puzzle input using straight lines, slashes to indicate turns, and pluses to indicate intersections. And there's some number of carts on all these tracks, indicated by arrows pointing in the direction the carts are moving when the simulation starts. We're supposed to detect when the first minecart crash occurs, assuming based on following the laws of how minecarts move. It doesn't say minecarts, but no one talks about carts except for minecarts, right? So there you go. They must be minecarts. In a given time unit, each cart moves exactly one in the direction it is facing, unless it is currently in. If it can continue going straight, it does so. If it must turn because it's reached one of these, it does so. And if it's at an intersection, it has kind of like a pattern that it moves. The first time it gets to any intersection, it turns left. The second time it gets to any intersection, whether it's that same one or another one, it goes straight. The third time it reaches an intersection, it turns right. And then it goes back to turning left. So this could be the same intersection 3 times, 3 different intersections once each. The cart doesn't know intersections apart from each other. It just knows that I turned left last time I turned. This time I'll go straight. It doesn't know where those turns occurred. And the carts also move in a prescribed order. The ones on the top row move first, starting from the left. Then the ones on the second row, and so on. And so our goal is to detect where the first crash occurs, I should say. Following all of these rules. So what I've done is just like, as I said, what I would describe as modeling work. I think this is a much more detailed domain model than you really have to build for this problem. There's a lot of shortcuts you could take that would result in less code, I'm sure. But I like trying to translate the problem into the programming language in as high fidelity a way as possible, typically, and then describe the solution to the problem in terms of the language the problem was given in. So, for example, many people who solve this would not bother modeling northwest, south, and east. They might model them just as unit vectors. North would be the vector -1, 0 or something, right? And likewise, these turns are maybe a little bit too more detailed than necessary. So what I decided is to just start saying things to Haskell that I knew were true from the program and see where that gets me. A coordinate is a pair of ints. There's 4 directions. A minecart can do any one of 3 things when it reaches an intersection. And a cart is a direction that it's going and what it plans to do at the next intersection. Something I tried earlier but then rejected was, what if, instead of a single turn, what if it were a list of turns, which is its entire future plan for the rest of the world? And then you could, when it's time to turn, you could just pop one off the front of the stack, right? And I think that would be totally fine. However, it turned out when writing parse tile that the natural way to write parse tile would have involved all minecarts sharing a reference into a single list of turns, and then like we'd run into memory leak issues if one of them advances very far through the list and one of them stays very near the front of the list, then we sort of keep the whole list in memory. So instead, I just said carts just have a plan for what to do next, and I'll just look up what the turn after that should be. Now, terrain is kind of interesting. We need to model... I started by just having this be like tile. I had merged the terrain and tile types, and then I realized it didn't really work very well. I think it's useful to have a terrain layer of the map, and then on top of that, sort of a cart layer telling you where all the carts currently are. Because the terrain never changes, but the carts do. So any point on our grid has some terrain. It may be empty, it may be straight, it may be an intersection, or it may be one of the two kinds of turns. I like to just describe these as... you can't like call them left turns or right turns, because like, for example, looking at this tile, if you're coming at it moving east, it'll point you north. That's a left turn. But if you're coming at it from the north, it'll point you west, which is a right turn. I'm pretty sure I said those in the right order. Anyway, so I call this turn an east-north, west-south swapper, right? If you're heading east, it'll point you north. If you're heading north, it'll point you east. If you're heading west, it'll point you south. If you're heading south, it'll point you west. So those are the two kinds of turns we have, the wuns and the inus. I previously called my directions left, up, down, and right, but I find I get confused about those when I'm talking about turning left and stuff. But it did make this easier. This was like lurd and droll or something. No, those are the same, but lurd and durl, maybe? No. Anyway, there is some way to make those somewhat pronounceable, but I don't remember what it is. And then additionally, there's a tile, which is the terrain of the tile and perhaps the cart currently on the tile. Our input type is as yet undetermined. I expect it will be an array of, well, yeah, something like that. An array of things. And so I wanted to use an array. And I wanted to go back to the ST array approach that I had tried in a previous puzzle and found it was too much of a pain. Here, again, a map would, in principle, be fine. And probably also fast enough, because we're going to be looking at relatively few of our points in each time cycle. But on the other hand, creating a new copy of the map is still somewhat expensive. So I thought I would try my hand at ST, but I haven't actually written any of this stuff yet. I just have some imports in. Parse tile is like kind of tedious, but not that difficult. I just defined two helper functions for like create an empty terrain based on, or create a terrain with no cart on it from a specific terrain type, and then create some terrain with a cart on it based on the direction the cart is currently headed. And if you couldn't parse it, return nothing. So, then I have to like describe a bunch of, how these directions relate to each other. The next plan is a function taking a turn and producing a turn, and this is just the cycle of like the three directions you could go. Again, we could do this in a more simple way, or a shorter way, by just like converting to int, adding 1 and taking a mod 3, and then converting back from int. That's something you could do. But then it's very fragile. If anyone like reorders the ordering of your enum here, it would break. And I did give this deriving enum because why not? And in fact, actually, this should be enum too. I don't currently anticipate using that feature, but like maybe I'll want it. Who knows? Turn takes a turn and a current direction and gives you a new one, and it like kind of stinks, but We're gonna have to write something similar for the Winez and Nuez as well. And it's just like a case match on first the turning rule and then the current direction. Again, tedious, but we've described how compass directions work now. How to translate. Given a current direction and a coordinate, what's the coordinate in that direction from where you're coming? Here it is. And this basically... So notice, by the way, that I have used y-x coordinates here. The problem statement tells us that locations are given in xy coordinates. So we'll have to translate to that at the end. But y-x is substantially more convenient simply because the first coordinate is what we want to sort on first when we're choosing... when we're choosing which cart to move next. And I plan to have like a map or a set, I guess, of coordinates which currently contain a cart and iterate over that. So it's nice for them to be in the right sorted order. Okay, so let's pick up where I left off, I guess. We've got some more drudge work ahead of us. Let's say bounce is a function that takes a... Ooh. This actually should be a curve of curve type, I guess. And I guess this is really not... Oh, yeah, it could be enum. Why not? But data curve equals that. So what we really ought to say is tile of curve this way, because I don't want to write... I was going to write a function. What type would we have given bounce a moment ago? It would have been a function from... I'm not sure which argument is the right one to have first, but tile, direction, right? But the problem is this is too big a type. Tile, or not tile, it would be terrain, I guess. Terrain has lots of things where curve really is not, like, where calling this like change directions doesn't make much sense. Really, it should only be called for these specific two, and so we need a new type for that. Curve extracts out and is a type of the right size. The other possibility is that we could write a function which takes in a tile and decides like what direction to go from there based on the cart on that tile. But I don't think we're going to do that. Yeah. It'll make sense. It'll make the most sense to just have this only work for these two curves. Okay. So instead of taking a tile, it takes a curve. And bounce Winez d equals case d of bounce Nuez. No, those are the same. Well, let's call this one news. At least I can pronounce that, right? And this one will be sewn. All right. Now I have to go change this thing here, but let's see. This is news and sewn. Those are actual words. So this is a sewn, and this is a news. No, it's not. Yeah, if you were going north, it points you east. I keep getting confused with like if you were going north versus if you were coming from north, but okay. bounce news d case d of. Oh yeah, it won't. There we go. So if d is south, we get east. East, we get south. Actually, hang on. Can't I have No, I can't call turn left because these don't always turn you right. They reflect you between two directions. They don't rotate you through four reasonable ones. West, north, north, west. Here we have north, east, east, north. It's very exciting, I know. I hope you guys like this sort of relaxing voice that I'm, I don't know, just sort of sing-songy, going through the Haskell blah-de-blah, talking about directions, la la la. You're asleep already, right? Fine. So we have all this stuff. I think we're ready to implement parse now. Sort of? What are the constructors in, like, how do you make an array in ST array? Like, you don't exactly. Data array ST doesn't do that. Neither data array M array does. And it produces one in a particular monad. So how do we get the bounds exactly? It's, I don't know, I mean, it's a bit lame. I guess we can produce a list of tuples of, no. What I want is just a list of items and a bounds. And I think I can get the bounds while parsing the items by producing a list. New list array. I think, I mean, yeah. Okay, well, parse of S equals, let's just do it this way. We'll define our input type, I guess, as a pair of two coordinates and a list of tile. That'll be the bounds. Actually, we only need one coordinate because we know the beginning one will be 0, 0. Right? Yeah. And then we can just, like, keep track of X and Y. Yeah, okay. Parse equals go of zero, zero, where go of empty string equals, no, go of pause and empty string equals pause, empty string. Very easy. Go and bleh. I don't just want go to be manually recursive, right? I want to fold over the lines. Is this a fold map, maybe? Not really. I want to fold over the list of lines given to me. Fold our go of, and what is that, our initial value exactly? The obvious thing seems to be, I don't know, this doesn't feel like a fold R exactly. I'm gonna write it just like recursively and see exactly where that lens leads me to. We have a list of lines. So if there are no lines left at all, then fine. Go of an empty line cons to some other lines is then... Oh, don't call it lines, x's. Don't want to shadow this lines. Is then just go... Oops. And we're doing these in y-x order. So y, don't care about x, is equal to go of y plus 1 and 0 and x's. Right. Go of xy and x's cons to more is equal to what did I call the parse tile? Parse tile of x. No. It's go of x plus 1 y and or applied to parse tile x. No, it's more than that. It's I have to call go equals case go this this is just x's cons to more, right? Of no, I don't have to case match because I can just fmap over it. Let's see. Fmap parse tile x cons 2 over this. Conflicting, we'll call this one C then. And this as well. Okay, doesn't compile, but can't make, you can't derive enum for things that have, yeah, I guess that's true. Yeah, so couldn't match type maybe tile with tile. That's fair. Because actually, parse tile returns a maybe of tile. Ugh. Okay, so first of all, this needs to return maybe an input, right? And let's give go a type so that Haskell can help me out here. Go takes a coordinate and a string and a list of string and produces maybe an input. All right, now tell me what's wrong. Here, fmaps and go. This makes sense. In the second tile with maybe tile. Okay, so we have to do something a little fancier here. Let's just use a do. This would be simpler, wouldn't it? Do tile, take tile from parse tile C. That's easy. Now let's make the recursive call. Rest from here. And then, let's see. What we got back from rest was an input. So we should destructure it into a pair. Except we don't have to, because I don't care. I don't want to change the coordinate part, just the part after that. So really, I can say fmap tile const onto and fmap that over go. Not quite, right? Okay, cool. So this compiles. Let us do something interesting for a change and say part 1 produces, get rid of this type. Part 1 equals identity. Just show me, like, print out this gigantic list that we're going to have. I just want to make sure that we have successfully parsed. And if it says nothing, then we've probably failed. Okay. Looks pretty good. I think it was right, actually. Right? The only undefined was that part 2 wasn't defined yet? Yeah. A bunch of tile straight nothings, but like in the very bottom right corner, there's a tile curved news. So let's just look at our input and see if that's correct. Yeah, there you go. Easy. And we should have seen, like, at the beginning a bunch of blanks and then another. Is that's not a, yeah, that's a news also, right? Well, okay, I don't want to scroll through all this. I can't scroll through all that. I don't have that much scroll buffer. But okay, seems like the parser pretty much works. Oops. So you know what? Let's get that committed. Day 13, part 1, complete up to parsing. So now we need to write part 1. Part 1 of I and tiles equals, probably going to need to do. We're going to be in ST a lot here. And I'm going to try to get various parts of the computation out of ST when I can, but we need to start working with an array pretty soon. So first thing we're going to do is make a new list array. So A is from new list array from 0, 0 up to I, and our tiles. Having done that, what I next need is to figure out where all the carts are. So has carts well, I guess we need to first get all the coordinate pairs with their contents into a list. So soaks from, and what is this function called? Get soaks. Yep. Of A. Let has carts equal S. Import data set as S qualified. From list I for, call it IX, whatever. For each index, and so now we're looking at the tile, right? Tile anything, just anything in soaks. So we're pattern matching on the association list for tiles with any terrain where the maybe cart is a just, and returning only the indexes from that. And now we have a set of places where carts are. Okay. Still not exactly clear like how to do a good job running this simulation from here. I guess what we want is now some kind of loop, some recursive function that runs a single time step. But we don't even want to run a single time step, right? Because, well, okay. The time step can return either a list, or sorry, a coordinate where the crash occurred, or else a new state to work with, right? Okay, so let's do that. And say, and does that need ST? It should, because it's going to have to write to the array, right? And read from it as well. Okay. So what we're going to do is say, let's then have y and x be taken from, well, yeah, run until crash of A and has carts, and then return xy. Okay. So run until crash is a function from part 1 is also going to have a weird type because what I really should do is say run st of do, right? What's the type do I have? Data array st is an st, run st, takes a function for all s, stsa and a, produces an a. Sorry, you guys can't see this, but it doesn't matter. Run st has the type we wanted. Run st of do. Okay. Run until crash has type. This is more complicated. Array? Wait, what is st array exactly? So we have an array. Oh no, array is a type class. St array is the actual specific type we're using rather. So it's an st s, and is that correct? Yeah, and st array s. No, hang on. We have an st array s and pair of coords. Whose contents are tiles. And we also have a set of coord. And from that we can produce an st of s whose contents are a coord. Okay. So run until crash, I guess we'll delegate to something that runs a single time unit for each cart, which will delegate to something that runs a single time unit for a single cart. And I think all of these have to be an st, which like super stinks. One second. Getting too hot in this room. All right, I mean, it's looking messy. I'm sure someone else has written a much, much better solution to this. But at least this is like it's all very explicit. And I get to play with st arrays and see how that works. So, sounds fun. Run until crash equals, no, of a, well, first of all, this really needs to have a type alias. There's no way I'm typing that like 7 times. Type grid s equals this. Grid of s. Call it g. Carts. Should these 2 arguments be they should be wrapped up in a new data type, right? Because I'm going to want to return, well, no, because we don't actually need to return a new array. We can just mangle the existing array, right? That's how this works? I mean, it says mutable, and st is all about like refs, so I think we can. But I guess this would be a way to find out, right? Like, to make sure. I'm not sure what the... I was thinking of, like, making a run until crash, just modify the grid somehow, and having part 1 verify that that modification has occurred. Sure. Let's do this. I guess part 1 has no real specific type at the moment, so I can just say carts. No. Top left is read array. What's the order of arguments to this? Read. It's in... Okay, M array has... Read array takes the array first, then the index. Read array A 0, 0. Okay, we'll return this. And then here, I'm going to say do write array, which takes the element last, of G and 0, 0 to be tile straight nothing. Okay. Oops. Pure 0, 0. No instance for num coordinate. Isn't it our grid takes a pair of coordinates? Oh, right. It's not indexed by a pair of coordinates. It's indexed by a single coordinate, which is a pair of ints. It compiled. Shocking. I didn't really expect that, but all right. Tile straight nothing. So we put a straight nothing in there. And let's just be extra super sure that we can write whatever we want in here. Tile straight just cart north go straight. I know it'll be exactly what we said, but I just want to be super sure that we can write the array from anywhere. Tile straight just cart heading north plan go straight. Perfect. Okay, so let's not actually do this. Just wanted to verify that that kind of thing was going to be allowed before I got really deep into the implementation of it. So run until crash G of carts is case run, no, I'd say do. New, let's call it carts prime, I guess. Should be, no, result, run one tick of, I guess I do need to pass it G in carts, okay. Case result of left whatever left of crash to be just pure crash, and right of new state equals right of, let's say, carts prime should then be run until crash I don't... It feels a little bit silly to be passing the graph around, the grid around over and over if it's never going to change. So I guess it's go, where go of carts equals do go of carts prime. All right. Run one tick is a function taking a grid of S and then S set coordinate and producing an STS of either coordinate or S set of coordinate. So if we've crashed, we say where, and otherwise we say here's the new carts you should track. Yeah. Run one tick of G equals go. Seems reasonable, right? Well, I kind of want to like fold M somehow, but I don't exactly, because I need to fold over like a state of an, or an ST of an either, and like that's kind of hard. I don't want to get out monad transformers, so I don't think I'm going to do that. I'm just going to run one tick G and carts equals well, maybe this is fine? Because I want to call run one cart for each item in the set of carts and allow that to modify the grid as it goes. And I additionally want to stop if I ever get a left back, which should be possible. So that looks like, and I can have that thing return. Okay, let's give run one cart, or move one cart, takes not this time a set of coordinates, but just a grid of S, and produces either a coordinate, an STS of either a coordinate or a different coordinate. It feels a little bit silly, but left as if it crashed, right as if it moved somewhere new and needs to be updated. Oh, this would be a capital T and ST. Move one cart of G. And it needs a position as well. And pause equals do. How can this be highlighted? Oh, I didn't finish this. Okay, sure. Do undefined, and now, okay, right? No? Oh, I didn't indent it? There we go. Okay, so this is, it's just upset about move one cart. So what we should do next is read from the grid. And when we read, we'll get a tile, which we know will have maybe a cart. or we'll have certainly a cart. So let's actually read tile T and just C. Maybe we should destructure cart as well, but probably not. Should be from read array G and pause. Then we need to move according to the terrain that we are on. No, I'm going to update carts after they've moved forward. Update their direction after moving them. So let pause prime be, I think we called it translate. Actually, we don't even care about what the old tile was. Pause prime equals translate. Oh, come on. I called it translate, right? Don't give me this for all TT nonsense. Takes a direction and then a coordinate. Translate the heading of C. Pause. And we've done that. So next, we need to read what is in the square we are moving to. Tile T C prime, the cart that might be there. Read array G pause prime. Case C prime of, and if it's a just of anything, then we can safely return pure of left of pause prime. We crashed right here, right? And otherwise, Norhing, nothing. There is no cart there, but we care about the tile. Case well, we have to do a few things. First, we have to erase the cart from the position it was at. So let's do right array G old pause I guess we needed to know this after all. And what we must write there is tile T nothing, right? That's all. This has the wrong type, which is fine. We're not done yet. And then case T prime, the new terrain that we're moving to will determine what direction the cart should move in. So let's let dir prime equal case T prime of, ugh, such a mess. The only things that will turn us are curves and intersections, right? Yeah. Intersection should be what did I call this function? Next plan? Next plan of the plan of C prime. If it's a curve of curve, then it should be oh shoot. It's more complicated. We aren't just updating the direction. We're updating also the cart's new direction it should point in, right? That is to say, its next plan as well as its current heading. So we're actually building a whole new cart, and might as well just say that explicitly, right? So it's a cart of next. Cart takes its heading first. HP, heading and plan. Next plan of P. Wait, hang on. This was backwards. This is the one I wanted to structure, the old cart, HP. Just cart of H and P. It's a good thing I used C prime here, which would have been definitely wrong. And it takes its heading first, cart H, next, no. It's an intersection, we should call turn by P, H. If there was a curve, we should call cart bounce by curve the heading and just leave the plan alone. And otherwise, it should simply be the old cart. Change nothing about it. And it's just upset that we haven't returned something, but none of the types yet fail. So we have a new, let's let new cart. And write that cart into the new position. Write array g pos prime, a tile with the same terrain as was there previously, and the new cart. No, just the new cart. And this still fails because it's the wrong type, but that's all right. We simply return pure of right of pos prime. Right? Okay. So move cart type checks. How could it be wrong? Honestly, this is the kind of Haskell code that can easily be wrong. They say of Haskell, if it compiles, it must be correct. And you've seen that that's often been the case, although not always. But this is the kind of like messy imperative junk that could be wrong in a million different ways. I don't know. It's modeling a rather intricate state machine and like doing it in a pretty delicate way, I guess you could say. But all right, well, here we are. So what I want to do now is, I feel like there's some clever thing you can do with traverse here. But I'm not sure exactly how to do it. So I'm going to try just writing it with do in case, and then see if it comes up with something interesting. Is do. I can't even, like... I guess what I want to do is build up a list of ST actions, right? And I want to get those by mapping move one cart. And then I probably want to execute them, but actually I want to, like, traverse them or something. So let's let moves be... I don't even need to bind this. Let moves equal map move one cart of G over carts? Is that correct? That should be okay. What is the type of map? Does it take a foldable these days, or it doesn't? Why? They changed it back, I think. What's... I mean, okay, S dot... I don't know, it's in foldable toList. toList... but that's in foldable, right? S toList, I guess I can just use that. Like, the one in foldable should be fine, but okay. Like, does this type check? It does. Okay, so we have moves. Fine, we built some moves. What do I want to do with them? What exactly are these moves? I have a list of... What did I just do? I hit page down a few times or something? I have a list of ST of either stuff. Well, I have a list of STs. If I were to, like, sequence that, then I would have ST of a list of eithers. But that's not what I want. Because that would execute all of the operations. I'd have an ST of a list of eithers. All right. It should be, what it should be is this. It should be go mapping. I don't know, guys. I need to write like a recursive thing, and I don't know, man. Do. All right, let's put this back where it was a minute ago. Now I have a list. Maybe I should just run all the actions, right? That'll be fine. It may mess up the state of the array somehow, but I don't care. I'm going to throw this array away if what I get back, if any of the ethers is a left, right? I don't care. So let's say let's see. Put let moves back. And what I want to do is map M, which is really just traverse. I have a list of st of things. Yeah, so actually what I want to do is just say results should come from traverse this. No, this is not at all correct. All right, give me back. Just let me do it in baby talk, will you? Like, I don't know what I'm doing. I'm a little kid. Now I have a list of st of things. I want results to be sequence A of moves. That is typed. That is correctly typed. And whenever you write map and then sequence A, you should have written traverse. But I can't. I mean, really, like, I guess I should be calling traverse this over carts. No, why not? I don't know, guys. Wait, why is this not type checking all of a sudden? It type checked a minute ago, didn't it? Oh no, this one still has traverse. Map. And get rid of all this stuff too. Man, how did I get to be so bad at programming? Okay. It must just come naturally to someone who's bad at so many video games. So I have a list of results. And now it's actually a list of ethers. I've already unwrapped the st. And so what I want to do next is case sequence A the results. This is a sequence A in a different applicative. We're not unwrapping st, we're flipping from a list of ethers to either a list or a coordinate, right? Of goes up here. Left crash is just pure crash. This is the kind of thing that, like, absolutely should be some kind of monad transformer of, like, st of either, where we could just do a bind that would, like, if we ever got a left, it would immediately return. Actually, does st exist? Like, is there a Haskell st transformer? Control monad st trans. Look at that. This should not be used with monads that can contain multiple answers. The state token will be duplicated across the different answers. Safe. Okay. So STT. In principle, I think we should be using this. And it comes from st monad trans. I don't know. I'm not going to mess with this. But I think in principle we should. It would simplify these, like, cases where we have to case, you know, this and here, right? We're just, like, looking at a result. If it's left, we pure, and if it's right, we do something with the results, and that's kind of lame. Pure of left. Oh my god, we even have to rewrap it. Unbelievable. And otherwise, it's a right of new cart locations. then we should pure, not do any st, but return right of carts prime. Is this right? This doesn't look right. Ah, we need to wrap it up in a set. Yes? Yes. Okay, so this is so brain dead that we can do it better, right? We can take sequence A results, call pure on it, and then fmap s.fromList over that. So we can return pure of fmap s.fromList over results, like so. Great. Well, it all compiles, right? What could go wrong? I mean, I don't know. I'm game to try it. What happens? Error. Called undefined array element. What? Oh, whoops. We have go of x plus 1. Our x's and y's are all mixed up here. So we were saying, so our coordinates are y indexed. This should be y and x plus 1. All right, try again. Error in array index. Error in array index. That doesn't tell me anything. So, okay, let's first talk briefly about new list array. It takes a list of coordinates and, sorry, it takes bounds, the lowest and highest index you will use. And, oh, actually, I don't know how it interprets, how indexing understands a tuple. Which one does it consider to be the major order? How would I find that out? Let's look at the type, like this IX module, or type class, I guess. IX. Hey, I'm back. I realized I just cut you guys off a minute ago. I hit Control 1 instead of Alt 1 when I was trying to switch to showing you this. I was trying to figure out how the indexed type, how it whether it handles, you know, an A-B pair the way we want it to, and it does. For each, it first iterates over the entries in the first of its tuples, or the first entry in both tuples, and for each of those, it iterates over all of the entries in the second half of the tuple. So that's correct. We wanted to iterate over all the, for each y, we wanted to iterate over all the x's before moving on to the next y. So that's fine. That's correct. That's what I wanted. And so that's why a new list array, starting from 0, 0, going to our max y, max x, will be in the right order. And new list array just like assigns indexes in ascending order. And indexes are ordered in the way that we want. Okay. But, like, what even happened? I don't know. It just said error in array index. I mean, I guess that tells me that the error was in move one cart. That's something, right? So let's talk through this this function a little bit more. We're given a coordinate and a grid, and we read from the grid the coordinate that that thing is at. And it's pointing in some direction. And we know it's safe to move in that direction because we last cycle pointed it in the correct direction. So we simply translate along our heading. Oh, I don't even have to call heading C. I can call H. And the position. Then we read the tile at our new position. And if the cart that was there exists, we simply return left of that new position to say that we crashed there. Otherwise, there must have been no cart there, in which case we Is there some reason that the ordering of these things matters? It shouldn't. We don't have any lazy values that like refer to stuff that we're about to overwrite, I'm pretty sure. We write to our old position the tile that was previously there but with no cart on it. Then we determine what new cart to write at the new position by looking at the terrain. Not the terrain onto which we are moving. Oh, yeah. The terrain onto which we're moving. Because if we move forward onto a turn, we must then turn before the next cycle, which will move us just forward. So, if there was an intersection there, then we produce a new cart by turning our cart according to its turn plan from its current heading. And we set its turn plan to be the next plan after that one. Then the other possibility is that there might be a curve of some sort where we are headed, in which case we build a new cart and we change its heading by bouncing from that curve, or let's say along that curve from our current heading, and leave our turning plan alone. If we had any other type of terrain, we simply return the old cart, leaving its heading and turn plan the same. In any case, we write to the grid at our new position a tile whose terrain is the terrain that was there before, and the new cart we constructed. Then we return the position. Okay. So it's not really clear where to go from here. There's a few things I could try. And I think that the most straightforward of these is to take the example from the problem statement, which is this, and try that first, right? and just see if we get the result that we should. And we probably won't. In which case, I'll want to update, yeah, error in array index. Probably use like some kind of drawing in run until crash, I guess. Or maybe run until tick. Or run one tick or something. And I guess, like, we'll just use debug trace. This is another case where it would be useful to be in a monad transformer, so I could, like... it could be like a writer, and I could tell the current state, or I/O, and I could print it. But okay, we're just debugging, so let's use debug trace. And what I want to... Well, okay, let's also look at part 1. Is it, like, really like silly? Is there anything awful here? Just run until crash of has carts, and it's hard to see how this could be wrong. Yeah, so let's just have run one tick. Well, move one cart, I guess. Can print the new thing. Trace show grid G. And we have to define show grid now, which kind of stinks. Show grid is a function taking a grid. Oh. I can't even use debug trace properly, can I? Because I have to say S. There you go. Takes a grid of S and produces an ST of S and string. Show grid of show grid equals no G equals go of, maybe I did go of no, I guess I need to say get a soaks of G bound to go where go of, yeah. Now if there are no soaks left, it's and it's like it's gonna be how do we get the coordinates? We have coordinates, but I want rows. I don't have those. Okay, well, I guess I don't want the assocs exactly. I just want, like, okay, maybe what I'll do is I'll just, instead of actually drawing the graph, I'll just print some useful information about what's happening. Trace of moving cart from show pause to show pause prime. And apply this to pure nothing. Missing a plus plus here. This compiles again, so that's something. So how far did we get? It never succeeded in moving anything? Okay, well that's just nuts, right? I mean, I guess I can put this here. Before we even do a write, nothing happened. Why? How? How is that even possible? Is translate wrong? That's possible, I guess. Trace read pause show pause. I just want to get some output to verify the debug trace is even like working for me here. Read to 0. Well, that seems like it ought to be fine, doesn't it? Parse produced an input. I mean, so what exactly did we return? We returned 13.0. What? Why 0? $13 is a correct. Oh. Okay, so first problem is that this line doesn't, like, there's no characters below this. So if our longest line doesn't go all the way to the edge, we choose the wrong bounds for the array. And apparently, like, no. I don't know where the 0 is coming from. Oh, no, I do. Because we got to the end and said, ah, there's an empty line cons to some stuff. Let's start a new row. Is that right? I mean, it's wrong, but like, is that a correct description of what is actually happening? Okay, so the first problem is we need to actually compute the maximum that x ever was. And in fact, I bet my input actually does have, like, spaces here. Yeah, Emacs just removed them for me. Does my real input have that? Because I didn't give that one to Emacs, right? It's a little bit hard to tell. Long line, no. Line, isn't it long line? Line, wrap. It's like called long line mode or something, I thought. The mode that makes you, yeah, okay, well, some lines go to 149 and We've seen some that only go to 148. And I'm pretty sure that this was written... Oh, no, actually... I did fetch this one actually with Emacs and write it. It was sort of more convenient to do today than running my little script because of what doesn't matter, but... So, okay, it's Emacs's fault. But of course, it's my fault. So we need to fix parse before we can make any more progress. Parse. I guess what I need to do is here. Okay, wait, also I'm like, this is ridiculous. Man, go YX. Ugh. That wasn't the problem, was it? Okay. That explains why things were wrong. Like, even accounting for the fact that I'd made an error, I couldn't understand how we would have gotten 13-0. That explains that. Okay, but actually what I need to do is this. I need to do here, y prime x prime from this go of... This is so weird. What a mess. And then pure of... I don't even need to compute... I don't need to save y, right? Because I can just add 1. Okay. I only really need... max, right? Oh, and give me the constructors, please. So really, go of x. I need to, let's see, maybe an input where an input y x prime comes from this. Just pass my existing x. Pure of y plus 1 and x prime, because we are starting a new line. And we've already passed down our x. Go of x 0 x, right? Now the trick is when there's actually a new go x and there's a new line, I need to parse the tile and then I'm still not totally sure about this one. When I'm adding... Okay, what I need to do is here, when I'm computing a new line, I need to say go 0 and x x prime to choose the biggest one. Right? Oh. Case of S of, wait, yeah, this is horrible. I guess I actually want to fmap a function. Oh, fmap mk coord and then I need this like mk coord of, we're returning a y and a max of x. So y max x tiles equals y x tiles, right? Okay. So we parsed a tile. I got an x. I don't need my y anymore. Oh, and now I can't add 1 anymore. Go of max get max x. Oh my god. Data monoid. Okay, it's in data semi-group with a lowercase g. X go x is a coordinate? How? Well, it does say so right here, doesn't it? It should be max of int now. We changed that. Whoa. Go 0 is incorrect. This should be max 0. But pure okay. God, this max of int thing blows. Like, I should just use ordinary ints. I just love, like, recognizing monoids and using them. Is that so wrong? Why is this what lights up? I have a max somewhere? Yes. Okay. Well, alright, this function is pretty stupid now, isn't it? Okay, now it compiles again. That's very exciting. We read a thing, undefined array element. But what did we return when we finished parsing? 613. 6 tall, 13 wide, is that right? 1, 2, 3, 4, 5, 6. Well, 0, 1, 2, 3, 4, 5, 6. So that's correct. And how about wide? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13, though. That's this. Okay, so I think we actually want to, like, subtract 1 from these. Because Haskell's arrays are, like, inclusive, and it's so weird. Yeah. Because it's supposed to be a min and a max, right? And if this is the min at 0, 0, then 1, 2, 3, 4, 5 should be the max. And 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 should be the max in that direction. So we really ought to subtract 1 from each. Sub 1, where, like, I don't know, sub 1, x, y, y, x, I guess, y, x equals y, minus 1, x minus 1. Like, really, we ought to use bimap or something like that. But I'm not, I don't know, I don't use bimap. No, that's not right either. Well, I guess I did want an fmap over it. I just needed to do t. All right, give me another go. What do we get back now? It should be better bounds, but that shouldn't actually have fixed anything, right? Because we shouldn't have ever read from any of those bounds. So we read the whole thing, 512. Seems right. And it's got, like, there's some carts in here somewhere, yeah. But then it, like, just never even... We... made this list array. I mean, I don't know. Let's trace show ID of this. Seems pretty awful, but like, let's make sure it prints okay. I don't know. We're not going to learn anything. Oh, maybe we did learn something. Because that never even gets called. Trace show ID produced a thing. Arrays are not showable, are they? No. So somehow trace made array. Like, does that, did we succeed in making the array? Yeah, that was made. And then it did get them. So why did it not show them? That is what bugs me. Huh. So, okay. Something about laziness, I guess? Alright, well, I guess I got some debugging to do, and this episode's gone on for, I'm not sure how long, but like a long fucking time, because I know I accidentally paused the recording partway through, and now I'm going to have to edit it all back together. Ugh. Anyway, I guess update tomorrow. Thanks for watching, and I'll see you next time.